Welcome to Creation Training Radio and TV. I'm your host, Mike Riddle, the president and founder of Creation Training Initiative, or CTI. At CTI, we have a mission of training other Christians to be able to speak about and teach about God's creation and biblical apologetics so that they can go out and train this next generation of our youth to be able to stand firm on their faith and belief in Jesus Christ, Creator and Savior. Now we have a very special guest again with us, Dr. Danny Faulkner. You were with us last week, and we learned a lot about astronomy, we learned cosmology, and we learned about stars and some major problems with the Big Bang. Now I promised that this week we're going to talk about something called comets, and we'll maybe talk some more about stars. And give us your background again, Dr. Faulkner.
Okay, for many years I was a professor at the University of South Carolina, Lancaster, where I taught astronomy and physics. Before that, I finished up my Ph.D. in astronomy from Indiana University. And at the end of 2012, I retired. They gave me the title Distinguished Professor Emeritus. Many people have commented it's the first time my name and distinguished have been used in the same context. And I quit that job, or I retired early from that job so I could take a position full-time at Answers in Genesis, which I began in January of 2013.
Well, we're glad to have you aboard with Answers in Genesis. It's a wonderful ministry, and they're doing a lot of great work out there, getting this word out to all around, not just the country, but all around the world, to people who need to understand the truth about God's creation. Well, Dr. Faulkner, why don't we start with these things called comets? Just what is a comet? And do you have some names of some familiar comets?
Yeah, these are mysterious objects going back to ancient times. The stars were pretty much fixed. We could depend upon them every season to be back where they belong, each night where they belong. The sun and the moon, they moved around pretty regularly. The planets a little more erratic, but still you could comprehend their motions. They're kind of restricted in one part of the sky. But comets occasionally would show up without warning. They would move across the sky, breaking all the rules, going in different directions, odd directions. They would suddenly brighten up. They would have a long tail that would come out of these things, pointing away from the sun generally. Comet, in fact, the word means tail, because it's actually not tail, means hair, coma. We get the word comb from the same root. Okay. So you have this tail, looks like a hairy star. And down at the end of the thing with the brightest part of what's called the coma, or the head of the comet. Inside of that, we see telescopically, there's a small piece there called the nucleus. The nucleus is amazingly small, just a few miles across. A big comet might have a nucleus 8 or 10 miles across. And that nucleus is made of various types of ices, water ice, carbon dioxide, frozen methane, and ammonia, with a bunch of dust thrown in. Now, the dust is not like household dust. It's microscopic solid particles. Okay. And collectively, these look kind of black. They're pretty, almost like dust of coal or something. And they're made out of silicate material and other bits of heavy material.
So this is kind of like a big dirty ice cube out there.
They call it a dirty snowball or a dirty iceberg or whatever. And its orbit's different from planets. You've got the sun here, and the Earth and other planets go around in a pretty much close to a circle. Technically, it's what we call an ellipse, which is like a slightly flattened circle. But if you drew on a piece of paper the orbits of all the planets, they would look like circles. Some a little off-center, but they would look like circles. Furthermore, all of them would lie in about the same plane. That is, you could draw them all on a piece of paper. Okay. You wouldn't have a planet orbiting like this, where all the other planets are doing this. But comets don't follow those rules. First of all, their orbits are very elliptical, so instead of being a near circle, it's kind of stretched out like this. So it kind of has a shape like that. The sun's at one end of it, so it spends most of its time very far away from the sun, where it's very cold. It comes in real close to the sun, much closer than the Earth is, in which case it gets very hot. It evaporates off the gases, dislodges the dust, and it fluoresces. The sun's radiation fluoresces the gases, so it gets very bright. And then the solar wind and the solar radiation pushes the dust and the gas back to form the tails. So only when it's near the sun, what we call perihelion, that means near the sun, are comets very bright. When they're very far away, they're very faint. The other difference is not only the orbit's very elliptical, but also they can be tilted quite a bit, up like this and down like that. So the orbits are very different from those of planets. And the fact that they have long periods, one of the most famous comets was Halley's Comet. It has about a 75-year period, so the chances of a person seeing it twice is pretty slim. You'd be very young and very old. And where we are in our orbit would be so much different that it would not look the same to you. Only when you studied the orbits, and people only got that ability about 350, 340 years ago to do that. we just start seeing similarities in comet orbits at that point.
I have a question for you.
Yep.
What's the difference between a comet and what they commonly call a falling star?
Okay, a falling star or a meteor is a piece of material. It can be a fragment of a comet or it can be a fragment of an asteroid. And it's orbiting around the sun. It happens to be at the same place at the same time that we're at, this Earth. And as it does, it's moving with respect to us, and it strikes the upper atmosphere and it burns up the upper atmosphere. Most of them do, at least. And when it burns up, it gets very bright and glows. Now, they only last a second or two and they're gone. Sometimes people say, oh, a comet in the sky. Well, no, it's a meteor, because a comet would be visible night after night. A meteor's just like that, it's gone. Amazingly enough, they're very small. I'd read this many times, how small they are, and finally about 20 years ago I sat down one day and looked up some things and did some computations. And sure enough, one that's as bright as the brightest stars in the sky, the piece of material burning up is about the size of a BB.
Wow.
People think it's got to be really big. No, it's very small. It's testament to the fact, two things. First of all, it's in a dark sky. It's about 60 miles up when it burns. But something that's pretty bright, 60 miles up, will show up very nicely in the dark sky. Second of all, these things are moving incredibly fast. They're typically moving 20, 30 miles per second. You know, when the Space Shuttle Columbia a decade ago burned up, it was only moving at about 5 miles per second, and it burned up pretty nicely. It was a big thing. If something is as big as a softball, part of it might actually survive to the ground. It would light the whole sky up, and that happens occasionally. Earlier in 2013, or back in late winter, you know, in Siberia, they had something enter, and it shattered windows and collapsed one building, I think, just from the shock wave, the explosion that ensued. And some fragments, I think, were picked up.
Now, you made a mention about these comets. They're burning up as they go around the sun. Does that present a problem for the cosmology of the Big
Well,
Bang?
it does. Not so much the Big Bang per se, but the supposed 4.5 billion year age of the solar system. You get comets that are going around in big long orbits like this. A comet's pretty flimsy. I mentioned it's like a dirty iceberg or dirty snowball. It's actually pretty porous. I sometimes think if you live in a northern climate and it's going to have a particularly snowy winter, shopping centers and malls and stuff, they plow up all this snow in the North 40, and as it evaporates away, sublimes and melts, eventually it gets this really dirty, dark, crusty-looking thing. I used to think those were like comet nuclei, but as it turns out, they're not really like comet nuclei at all, because those are pretty dense and pretty heavy. It turns out comet nuclei are probably 5 to 10 times less dense than that. There are a lot of holes in it, very frothy, so you could break them apart pretty easily. Someone's described a comet as being the closest thing to nothing you can be and still be something. There's not a whole lot there, and so every time they come around close to the sun, that nucleus loses a good deal of material. And there's a limit to how many times it could orbit around and still shine as a comet does. And in fact, I mentioned Halley's Comet. It's not as bright as it used to be. Other comets have died out. Some we've watched them, you know, from one trip to the next. It burned out to finally nothing is left. So it's obviously a finite lifetime. And we can run estimates of how big the orbit can be and still be orbiting the sun, and multiply by the number of trips it might take. And we find out that the maximum age that a comet can have is no more than maybe on the outside, a few 100 million years. That's with an M, which is just a fraction of the age of the supposed age, 4.5 billion years of the solar system. Comets can die out other ways. They can collide with a planet. That happened in 1994. Comet Shoemaker-Levy 9 catastrophically ended. It's not coming back because it's gone after that collision. Another way is they can be ejected from the solar system. This autumn, this is 2013, we're expecting Comet Ison to come close to the sun, perihelion, on Thanksgiving Day, and in December hopefully be a bright object for us before it fades pretty rapidly in the first part of the year. That comet is actually leaving the solar system. It's being ejected because it's come too close to some of the other planets, and it's being kicked out. That's been observed many times. That's a catastrophic loss. It'll never be back again. So enjoy it this time, folks, because you're never going to see it again. So anyway, you put all those together, and it's a severe upper limit. Comets really could only orbit maximum a few millions of years, not billions of years. If the solar system is 4.5 billion years old, there should be no comets left. So the fact that we see comets suggests that it's much younger than that. So if it's only, say, 6,000 years, as we creationists think, that's not a problem at all.
Well, wait a minute now. Is it possible new comets are forming or coming into the solar system?
Well, that's the comeback that they have.
They meaning the evolutionists.
The evolutionary astronomers. Back around 1950, there were two astronomers. One was Jan Oort. He was a Dutch astronomer. The other one was Gerard Kuiper. He was actually born in the Netherlands, but came to the United States at a young age and was an American astronomer by the time he was doing his work. And they came up with two possible places comets could come from. And you got to realize there are two types of comets based on their orbits. And what's called the long period comets. These comets, remember I mentioned that they're very elliptical, and they also have almost any inclination. They could, if the planets are orbiting like this, they can orbit like that. They can even go backwards, as it turns out, the other direction, what we call retrograde. Long period comets have orbits like that. They're inclined very high angles, and about half of them go the same direction planets are going, and the other half are going the other direction. And so Jan Oort suggested that far from the sun, very far out, thousands of times farther away from the sun than we are, the Earth. We talk about solar system. We have a unit of distance called the astronomical unit, or AU for short. That's defined to be the average distance of the sun from the Earth.
Which is about how far?
93 million miles, or 150 million kilometers. Well, they think, Jan Oort said, well, maybe 1,000 or maybe a few thousand AUs from the sun would be this
So take
comet
93
cloud.
million and multiply it by 1,000.
Or thousands. That would be kind of
Thousands.
inner size. It might be on the order of 10 to 20 or 30,000 AUs. So very, very far from the sun, you would have these comet nuclei orbiting like this. And occasionally a passing star or something the gravity of it might alter the orbit and cause it to fall in. And as they fall in, they would be replacing comets that are being destroyed in the inner solar system.
Now, wait a minute. Has this ever been observed?
Of course not. No.
Okay, so what we're saying is none of this evolution has been observed.
No. In fact, there's a famous quote from Carl Sagan. People of a certain age will remember him.
Yes.
He was a very famous astronomer back 30 years ago. And he has a famous quote from a book he co-authored in 1986. I think I can quote it, if not exactly, pretty close. He said there are many papers written each year, hundreds of papers written on the Oort cloud, its evolution, its origin, this sort of thing. But yet there's not yet a shred of direct evidence for its existence.
Is that still true today?
It hasn't changed. I mean, I could have said that. It's true, and it still is true.
So
there's no evidence. Now, they would argue, well, where did long period comets come from? Well, that's begging the question. You know, you invent this Oort cloud to explain the origin of comets, and then when you ask where's the evidence, you say, well, comets are here.
Okay.
And
so we're circular, and we're doing it, what you said last week, a rescue mechanism.
Rescuing device, yeah. Sort of like my neighbor. You go out and I see he's throwing orange peels on the yard, and I say, well, what are you doing? He said, I'm throwing orange peels in the yard. I said, well, I can see that, but why? And he says, to keep the elephants away. I said, well, there's not an elephant within 50 miles. And he says, see, it works. You know, so that's the kind of thing we're up against here. To people who really believe in the Oort cloud, they look at me with dumbfounded look. What do you mean you don't believe in that? Of course it exists. Well, it exists if you really, really, really wanted to, but there's no evidence for it. Now, that's not to say that it doesn't exist. I'm simply saying there's no evidence that it does. I don't think it exists, by the way. But
so what you're saying, it's really not about evidence. It's about our starting point, our worldview.
yeah, and you know, science, I always thought, was the study of the natural world using the five senses. If you can't see it, you can't smell it, you can't taste it, you can't hear it, you can't touch it, then it's not science. So I would submit to you that the Oort cloud is not a scientific concept. Now, one day it might become that if we can ever get to the point we can actually see these comet nuclei, but that's way off in the future, if ever.
Now, let me. Here's a great question I just thought of. If I'm talking to an evolutionist astronomer, I say, can you give me the observable evidence to support the claim of evolution in astronomy,
the Oort cloud,
evolution, without asking me to accept anything by faith? Can they do it?
What they would come back with is say that we've done these computer simulations of how this might work.
And I'm a computer person. I would say computer simulation is not science. It's called
I
garbage
agree.
in, garbage out.
Yeah.
In other words, show me the evidence, observable evidence, without asking me to accept
Mike,
my faith.
I've asked people astronomers who believe in the Oort cloud. These are Christian people, by the way. They'll agree with me on creation. And their response is computer simulations of how this might work. That, unfortunately, is the way things work now in astronomy. I'm very alarmed by it because all it proves to me is how good the programmer was. I mean, you can simulate almost anything you want.
And I've done that on computers before.
And if you put the input parameters, it's giving you a plausibility argument, but it's not really evidence.
No, it's not.
Now that's how we explain long period comets. Long period comets, not we, I should say, most astronomers explain long period
Now,
comets.
you mentioned the Oort cloud. How do you spell Oort? Just make
Double
sure
O-R-T.
Double O-R-T.
Yeah,
okay.
it's a Dutch name. So
Okay.
anyway, the Oort cloud is supposed to explain long period comets. Now I mentioned that their orbital periods are, the orbits are inclined at all sorts of angles, high angles with respect to the plane of the solar system, and many of them go backwards.
And you said long period. What kind of a period are we
Well,
talking about?
typically what we find is those kind of orbits I've just described have periods of about 200 years or
Okay.
more. Now, the other comets then are called short period comets. Their periods are generally less than 200 years. We've got to be very careful here, though. I'm going to explain something to you. Remember I said that the orbits of the planets are almost in a plane, single plane, and all the planets go in the same direction, counterclockwise, as viewed from above the north pole of the Earth. Well, short period comets, comets that have periods less than 200 years, typically have orbits that are lowly inclined, within 20 degrees or so of the plane of the solar system, and they go in the prograde direction. There are about 100 known short period comets. That is, comets periods of less than 200 years that follow that. Out of the 100 or so, there are 3 that have periods less than 200 years that have characteristics of long period comets, highly inclined, maybe going backwards. Unfortunately for us, the best example, if you ask people to name a comet, they would say Halley's Comet. That one is a 75-year period, which we think is a short period, but it's like a 75-degree angle, and it's going backwards. So it's actually a long period comet with a very short period.
Okay.
They think in the past its orbit was maybe altered by coming close to Jupiter or some other large planet that changed its orbit. That happens.
Okay.
At any rate, the Kuiper suggested back in 1951, I think, that the short period comets came from a reservoir of comets orbiting just beyond the orbit of Neptune, much closer, only talking 40 AUs, 50 AUs, 60 AUs.
Again, AUs being 93 million miles.
Yeah, not thousands as the Oort cloud, but only tens.
But it's within our solar system.
Yes, yeah. And these would be just beyond the orbit of Neptune and be kind of like a donut shape out there where they would be orbiting. And occasionally one of the outer planets, they're kind of big, would yank the orbit and cause them to fall in and continually rain in and replace short period comets.
So it's like a cloud of objects hanging around.
Yeah, yeah. And so they've been looking for these objects, and about 20 years ago, in the early 90s, they began finding some asteroids out beyond the orbit of Neptune. They said, aha, we found the Kuiper belt. Well, hold on a minute. First of all, the biggest comet nucleus ever seen was out of comet Hale-Bopp back in the late 90s, mid-90s. That one, they inferred its size to be about 25 miles across. That's the biggest. A big one typically is 8 or 10, 12, but this is monsters. It was huge. It was a bright comet too, by the way. But the objects we're finding out there are huge. In fact, people sometimes wonder what happened to Pluto. They now think it's one of the largest objects out there. It's not the largest. Eris actually a little bigger. And I have to ask myself, well, if these things are comet nuclei, where has the mother of all comets been? I mean, if you brought Pluto in, imagine the comet, how bright that would be. Plus, we know something about the composition of comets. They've been able to deduce that from some spectroscopy of them. We've actually been able to deduce the composition of Pluto and at least one other of these objects out there. Turns out the compositions don't match. The compositions are different.
And the planets?
Than between comets and the objects out here that we're finding. At least the ones we can actually probe so far, the compositions don't match cometary compositions very well at all, actually. And what's interesting is you can probably get comets to match that if you change some of the assumptions you make about it. You see, some of the things we infer about the composition of comets is that they're pristine examples of the original solar nebula from which the solar system supposedly formed 4.5 billion years ago.
And that's a whole nother situation.
It is. We won't go into that right now. But the thing is, if you want to try to match the known densities of the few objects out there, you have to give that up. And most astronomers are unwilling to do that. So there's a big problem there. They keep saying these things out beyond the orbit of Neptune are Kuiper Belt objects, KBOs for short. But I prefer the title TNO for trans-Neptunian object. That's a better description because it simply tells you where they are. They're beyond the orbit of Neptune. We've got a whole new asteroid belt out there. And I find it interesting that more and more astronomers are starting to call them TNOs rather than KBOs, which is interesting. I think they're beginning to realize that maybe there's a problem here.
So these objects out there, KBOs or TNOs, as you call them, as far as being the comets that come around and circle around our solar system, one, they're not the right composition.
I don't think
secondly, they're too big.
Yep.
So where did these short-term comets come from?
Well, the assumption is they would assume, well, these are just some of the bigger ones out there. If we keep looking, we'll find, they're finding smaller ones, by the way. There's a general assumption that when you find large objects in astronomy, you find smaller objects like them in much greater abundance. Among asteroids, that seems to be the case. And so they're kind of saying, well, there's a lot of small ones out there that really would match this, but that's not really in evidence yet. That's something that's for future. So can I sit here and tell you that there's no evidence for the Kuiper Belt? No, I really can't. I'm telling you that there is some evidence, but I think there's some problems with that evidence. We see these objects, but are they really cometary nuclei? But for the Oort cloud, the situation's not changed. It's not really been detected. It won't be for a very long time, if ever.
Now, if those objects are out there, would they exist out there for 4.5 billion years?
Never really given that much thought. The assumption is they're very far from the sun, they're very cold, and so they would stay frozen in that state for. You heat them up, though, they're not going to last very long at all. It's very cold out there. Typically, things out there at best are like 40 Kelvin, which is like 400 and something degrees below, almost 400 degrees below Fahrenheit. So they're very cold.
Okay. Now, comets are a problem, but they have the rescue mechanisms. There's no observational evidence for it again. Well, for the Kuiper Belt, there is some observational evidence because there are objects out there.
Problematic, but not for the Oort cloud.
But the Oort cloud, there's nothing. But those objects in the Kuiper Belt, there's still a problem because we can't quite match everything.
Yep.
Because again, they're not the right composition. They're not the right size yet. We haven't found the small ones. Now, I'd like to take us on a different course. We have a few minutes left here, Dr. Faulkner. What about stars? And when I read these books and I talk to the youth in these classrooms, they always talk about how it's taught as a fact. Stars form, and they always tell me we have these rotation of these nebula, gas and dust clouds, rotate around and around, and gravitation claps inward, and voila, we have a protostar and then a star.
The last time we talked about the fact that there are no observations that stars are forming. They have snapshots, they interpret that way. The rub is this. We can calculate, assuming we know how stars get their energy, we think it's from fusion of hydrogen to helium in their cores, we can calculate how long stars can last that way. The sun can last close to 10 billion years, but the universe is supposedly 13.8 billion years. So the sun could not have been primordial. In fact, they think 9 billion years passed before it came along. Other stars even worse. There are some stars they think the lifetime is 1 million years or even less, very short. More high mass stars are like that. So obviously many stars, including the sun, can't be primordial. They had to form sometime after the universe began. So in the evolutionary worldview, you have to have stars forming all the time, really. And they look out in space and they see large clouds, very thin clouds of gas, and they say, aha, they're made out of hydrogen and helium just like stars are made out of. They're made out of the same stuff. So the difference between a star and a gas cloud is the gas cloud's big and it's cool and it's not very dense, but if we contract it down, then all of those differences melt away. It looks like a star at that point. So all you have to do is get that thing to contract down. Well, so gravity must do that. These clouds are very distended, but they have a lot of mass, and so there is some gravity pulling inward. The problem is they're made out of gas, which is subject to gas pressure, which tends to push these things out. And so you have, you can write the equations, do the measurements and so forth. You can calculate the gravity, you can calculate the outward force of pressure. It turns out they're pretty balanced at this point. There's a thing called hydrostatic equilibrium, which works in a lot of things on the Earth. It also works in things in space, including stars such as the sun. And the thing is, if you contract the gas cloud just a little bit, you'll increase the gravity, but you'll increase the gas pressure even more. So it re-expands. We say these things are stable against collapse. Early in the 20th century, probably in the 1920s, a very famous astronomer named Sir James Jeans looked at this problem, did some computations, and he derived what we call the Jeans length, still established science in our field. And the idea is if a gas cloud for a given composition and size and temperature, density and temperature, is of a certain minimum size, then gravity can take over and contract it all the way down to form a star. But you got to get the gas cloud down to that point. As far as I know, all the gas clouds we've looked at, we're able to detect and measure, are many orders of magnitude too big. When I say an order of magnitude, it's a factor of 10. We're talking like millions of times bigger. So you've got to collapse this thing down and get it down to the Jeans length so that gravity can take over. And no one's really demonstrated how you can do that. There have been suggested possibilities of a shock front from a supernova that could do this. But all the mechanisms they have to do this all require that stars first exist. So even if these mechanisms work today, it doesn't ultimately tell you where stars came from.
Now wait a minute. When I read all these books and I talk to these youth who take these classes on physics, astronomy, even biology classes, they're never taught this information.
Of course
Why
not.
aren't they taught this?
They're trying to keep it simple, and they don't want to show them the problems. You have to really get into grad school many times. Not even in college will you see that. In my classes, I dealt with that, but in grad school many times is where you get to the nitty-gritty. By the time you get there, they've already got you hooked.
Yes. So in other words, they'd rather promote the evolution than teach the good science sometimes.
Sometimes, yeah.
Yes.
Unfortunately.
And that's a problem with our education system right there. Well, it's been a pleasure having you on, Dr. Faulkner, and we hope we can have you on sometime again in the future. We've got a whole lot of things to discuss about cosmology, including how do people try and fit it into the Bible again.
Yep.
And to end on one part, there's a scripture in the Gospel of Mark, chapter 10, verse 6, where Jesus makes the statement, "But from the beginning of the creation, God made them male and female." Jesus Christ, the creator of all things, is telling us man and woman were on the planet from the beginning of creation. How does that affect the Big Bang?
Well, the Big Bang, you have to have the universe around for nearly 14 billion years before people are around. And that doesn't work.
So either the Big Bang is true, and if Big Bang is true, then Jesus' words are wrong.
Or Jesus is right.
Right? And the Big Bang has to be wrong.
That's right.
So you've got it. The Big Bang does not fit into the Bible, and Jesus Christ, the creator of all things, said no to the Big Bang right there in an old earth. You've been listening to Dr. Danny Faulkner, a Ph.D. in astronomy, and I'm Mike Riddle, the founder of Creation Training Initiative, and we like to do these shows. We want to inform you because we want more and more people out there to learn the truth about God's creation. As it says in Psalm 19:1, the heavens do declare the glory of God, not a great big chance accident. If these lessons had been a blessing to you, you might consider financially supporting the Ministry of Creation Training Initiative. You can do this by going to our website, creationtraining.org. Again, that's creationtraining.org. Your tax-deductible donation of just $20, $50, or more a month, or a one-time gift of any amount will make you an education partner in building an army of Christian educators who can teach the biblical account of creation and train others to be able to defend their faith and be biblically faithful to God's Word as it states in 1 Peter 3:15. But sanctify the Lord God in your hearts, and be ready always to give an answer to every man that asketh you a reason of the hope that is in you, with meekness and fear.